Hello viewers, welcome to the massive open online course on engineering mechanics. Today we will cover the module 3 on equivalent force system under this unit 1, the moment of forces and couples. Earlier we have seen that the particle, that means when we call a body as particle when it has negligible dimensions compared to other dimensions in the problem, or its dimensions are not important in the solution. So, as the particle has negligible dimension, all forces are assumed to be applied at the same point. So, here we have shown a figure, that is a ball is shown. The ball is under lot of forces like gravitational force and the supporting force by the hand. All these forces actually pass through the center of mass of the ball. So, here in the analysis all these we consider all the forces are concurrent and they pass through the center of the ball. That is why we consider this body as a particle, because here dimensions are not of importance. Another concept we have come across, that is rigid body. All solid models actually deform under the application of forces, but for some applications these deformations are negligible. So, here we use the concept that rigid body, that is it has, we assume that there is no deformation, the body is rigid, and we use this concept in many ways. Now, how this rigid body is different from the point mass or particle? In case of particle, all these forces pass through the one point, it may be center of mass or particular point. But in case of rigid body, these forces applied on it are not concurrent. So, and they do not pass through the center of mass. Here we are giving one example, that is, in case of a ball all the forces pass through the center of mass, but here we have shown a stick which has negligible weight and a force is applied at its end and it is held by the hand. So, when this force is applied, the hand experiences two things. One is that force which it has to balance to keep it in static condition. Another, there is due to this force there is a tendency to rotate the stick. So, this is the one of the characteristics of the rigid body, that another thing other than this force, another new thing comes, that is called moment. And so, for equilibrium of a particle, these concurrent forces should be, the resultant force of these concurrent forces should be 0 for its equilibrium. But when we go to the rigid body, it is not sufficient, another restriction is required. Here in the one example we have shown, this body, there are two forces F1 and F2 which are equal in magnitude, but opposite in direction. So, these two forces actually resultant force will be 0, but these two forces creates a tendency to rotate, and this is the actually moment. This tendency due to the force is called moment. Here we are given one illustration of this moment. Suppose there is a shelf which is attached to the wall, and if it is weak, now we want to keep a television. So, if we know that this shelf is not so strong, what we will do, we normally keep the TV towards the wall, because if we keep towards the other end, what happened, there will be a tendency to rotate the shelf and ultimately it may break. Why this is the case? Because due to the moment. In the first case, the moment is, that is distance of the CG of the television from the wall, that is d1, and its weight is W. So, W into d1 is the moment, but in the second case d2 is the distance and W is the weight. So, here the product of d2 W will be more, much more. That is why we try to reduce the moment. So, we keep towards the wall. So, in the next slide we have shown these values MP. MP is the moment about that point P. So, in the first case d1 W and d2 W, here negative sign as it is clockwise. So, normally sign convention is negative. Now, what is the effect of a force? The effect of a force does not depend not only on the magnitude and direction, but also on the torque it creates. The rotation of objects such as wheel of a vehicle, the crankshaft of an engine and the rotor of an electric generator result from the moments of the forces exerted on them. So, if an object is in equilibrium, the moment about any point due to the force acting on the object should be 0. So, now the question is, this module, that is equivalent force system, why we study this thing? So, we want to actually study the methods of rigid body equilibrium. For this, it is necessary to study the effects that are caused by moving a force from one point to another on a rigid body. Actually, in engineering, there are system of forces and moments which are very complicated. Now, if we are interested on the total force and moment exerted on them, then we like to simplify these complicated systems by simpler systems of forces and moments. So, for this simplification of a system of forces and moments can be done by using the concept of equivalent force system. Now, in this unit we will study the following things, that is the definition of a force, then how to determine the moment of a system of forces. We can use the we can find out unknown forces by summing of moments, and the what is the nature of moment vector, then what is the Varignon's theorem and how to apply them, and determine the moment of a force about a line, and then what is the definition of the couple and how to determine the moment of a couple. So, here the main concept is moment of a force. This we can see here, we are giving one example, that is, suppose we want to rotate a pipe. So, we use pipe wrench, and we have seen that when we use the pipe wrench, we apply the force at the other end of the pipe wrench on the one, that is the far end of the pipe wrench, that force is perpendicular to that wrench, so that we get maximum effect. And also we try to maximize the distance d to get the maximum moment. So, thus we see that one effect of this force is to cause the pipe to rotate about axis A, and from this experience for efficient turning we control these two things. That means, force should be perpendicular and we will try to maximize the d, that is the we call moment term. Here there is a force F and a point P. We want to find out the moment of the force F about point P. For that, what we do? We have to find out the perpendicular distance from point P to the line of action of force F, and if we multiply this, that is the moment of F about P is m P, and that is equals to this distance d, that is perpendicular distance d, and the magnitude of F. By this we can find out the moment. And the direction, how we find out? Here we can see that due to the force F, this wrench is trying to rotate in anticlockwise direction. So, this direction actually we find out when if we curl our hands in the direction of rotation, then this thumb actually gives us the direction of the moment. And in case of in a plane we can show by an arrow. So, that is clockwise or anticlockwise, that way you can show the sense of direction. The force would tend to cause the counterclockwise rotation about point P, and if we imagine that the force gets an object that can rotate about point P, then force would cause counterclockwise rotation. So, thus the direction of moment is counterclockwise. So, according to the convention, the counterclockwise moment is taken as positive and clockwise moment is taken as negative. And what is the dimension of a moment of a force? As we have seen that it is a distance moment term into force. Force is, so force is normally in SI unit, the force will be in newtons and distance will be in meter. So, Newton meters is the dimension of the force, moment of a force. Here we are one example we will solve how to determine the moment of a force. So, here is a body, we are interested the 40 kilonewton force is applied in one end. So, in another end that is fixed end, there is a point A at the center. So, we want to find out the moment of 40 kilonewton force. Now, how we will do? So, there are actually two approaches how we will approach this problem. One approach is you find out the perpendicular distance from A to the line of action of force, and another approach is express the force in terms of components and then determine for individual component the moments and then sum them. These are the two ways. Now, in these two ways we will solve this problem. So, first method, that means if we find out the perpendicular distance from the point to the force. So, here from the figure it is easily seen that from A to the line of action of the 40 kilonewton force we drop a perpendicular, this perpendicular distance is d, and here from geometrically we can see that it is a 30 degree. So, length is, so this triangle, from this triangle we can find out d is 6 meter and sin 30 degree. So, it is 3 meter. So, this distance, perpendicular distance d is 3 meter and magnitude of the force is 40 kilonewton. So, the moment about A is 3 into 40 equals to 120 kilonewton meter, and as the direction of this is the force is trying to rotate in the anticlockwise direction. So, it is a positive direction. So, it is its sign is positive. Next, second method, instead of working with the 40 kilonewton force, we resolve these forces into horizontal and vertical component, and then for each component we take the moment. So, horizontal component is 40 cos 30 degree kilonewton and vertical component is 40 sin 30 degree kilonewton. So, for the vertical component distance is 6 meter moment arm, but for the horizontal component as it is passing through the point A, so this perpendicular distance is 0. So, its moment is 0 because moment arm is 0. So, only the vertical component will create the moment. So, in the next slide we see that this vertical component of force is 40 into 30 degree. So, the 6 meter is the distance moment arm. So, value is 120 kilonewton. Now, here we can have some discussion why these two methods give the same result. Actually, if you see that in the first case you are taking the given force directly, in the second case you are resolving the force into two components. So, these forces are actually concurrent force. So, according to Varignan's theorem, the moment of sum of the moments of all the concurrent forces equals to the resultant moment of the resultant force of those concurrent forces. So, this will come later. So, due to that in both the methods we are getting the same result. And another question is which method we will use, either whether we will use the directly we will take the perpendicular from the point about the point of rotation to the given force or to the components. Actually, it depends on the problem. In some cases these dimensions are such that or the data given is such that any particular method will be convenient. So, according to that we have to judge the method. Let us see another example how to determine the earlier only for one force we have done. Now, we are going to a machine part is there. So, here number of forces are acting on it. We want to find out the moment about O. So, here at O there is a downward force 3 kilonewton, then 2 kilonewton on the another position above this 3 kilonewton 300 millimeter above that, and on the right corner there is 4 kilonewton force, and in the horizontal line in the where O is there along the x axis there is a 5 kilonewton force. So, these are the forces acting on this machine part. We want to find out the moment of this system of forces. So, again we can find out the how we will approach this thing. So, there are two approaches. One approach is actually here approach is we can earlier these two approaches which we have done, that means components and actual force given. So, both these methods we can apply here. How we will do? Determine the moment of the forces about O directly from the given information except 4 kilonewton, because 4 kilonewton this determination of the perpendicular distance is not very straightforward. That is why we can go for component and then the distance for moment arm we can find out very easily, but other forces directly we can take case. So, just if we go to the earlier figure, just you can see that 5 kilonewton force passing through O. So, its moments will be 0. 2 kilonewton force along the x axis there is 300 millimeter distance is there, that is moment arm. So, for 2 kilonewton the moment arm, that is d 300 millimeter or 0.3 meter. Then 5 kilonewton, 2 kilonewton and 3 kilonewton is passing through O. So, its moments will also be 0, but the force 4 kilonewton it is not straightforward. So, what we will do? we will resolve it into two components, horizontal and vertical, and then we will take separately the components. So, all these calculations we are showing now in the method. So, moment of 3 kilonewton force as exert no moment about it passes through O. So, it is 0. Moment 5 kilonewton force, it also passes through O. So, no moment, 0 moment. Moment of 2 kilonewton force, so it has 300 millimeter and the here. So, it will have, as it is a clockwise direction, this force is creating. So, it is negative moment. So, it is 0.6 kilonewton meter, but for 4 kilonewton force we are going to find out the two components. One component is vertical component is 4 sin 30 degree kilonewton, horizontal component is 4 cos 30 degree kilonewton. So, if we take, so in first case, that means for vertical component the distance is 300 plus 400 equals to 700 millimeter, that means 0.7 meter, and for the horizontal component the moment will be it will be 300 millimeter, that means 0.3 meter. So, that we can see here the these two components 0.7 and 0.3. So, these two. So, in first case 0.3 into 4 cos 30 degree horizontal component, it is minus 1.039 Newton meter, and the vertical component is 1.4. So, if we add all these moments we get minus 0.239 kilonewton meter, and as it is negative. So, it will be clockwise moment. So, here one thing is, if the object is subjected to known forces, why it is useful to determine the sum of the moments of a force, forces about a given point. Actually, sum of the moment of forces is required when we want to examine whether a body is under equilibrium or not, then the sum of the moments should be 0. That is why we have to calculate the moment, sum of the moments about a point. Another application of this moment of a system of forces is in dynamics, actually for finding out analyze the angular motions, there we require the moment. So, that is why we find out these things for system of forces. Next, another example where we will find unknown force by summing the moments. In this example, we can see that here is a bar C A and it is tied to the point B by a cable, and a W weight W 150 Newton is the weight of the bar. So, that is at the CG, it is there W. The sum of the moments about C due to the weight, and it is given that sum of all the moments about C is 0, this is given. Now, we have to find out what is the tension in the cable. So, here what will be the approach? So, let us take tension in the cable B A as T. So, using the given dimension, we will find out what are the horizontal and vertical components of that tension T, and then we sum the moments about C, and then we know that sum of the moments is 0. So, that equation, that condition we will apply. So, let us see the solution. So, in this case the tension T is resolved into two components, and from the geometry using similar triangles we see that 3 by 5 T is the vertical component and 4 by 5 T is the horizontal component. So, now if we take the moment about C, the horizontal component, the moment arm is 4 meter, and for the vertical component it is also 4 meter. From the earlier figure we can see 2 meter plus 200. So, it is 4 meter. So, this way we can about the moment C, these two W, and for tension we take the two components horizontal and vertical and W. So, all these three forces, if we take the moments and equate to 0, then we can find out the unknown tension T equals to 0.357 W. So, that is 53.5 Newton. Again here the question may be raised, why we did not consider the forces at the support C. Actually here the, because we know that the moment of force about C is 0 and the bar, so the bar is in equilibrium. So, the sum of the moments about C is 0, it is given. So, apply this condition, we can find out the tension, that is why it is used. Next is the, now we will go to more detail that what is a moment vector, because in two dimensional case we have dealt with, but what is in general moment vector if we want to find out. So, the moment of a force about a point is a vector, and in this figure we see that force F is a force and P is the point, and about point if we want to find out the moment, then what we have to do, that is this moment about P m p equals to r cross F. R is the position vector and F is the force vector. So, r cross F is the moment vector m p. So, from the definition of cross product we know that the magnitude of m p will be magnitude of r, magnitude of F and the angle between r and F, that is theta. So, sin theta, sin of theta. This way we can find out. So, from the earlier definition we know that the moment is equals to magnitude of, that is magnitude of moment equals to magnitude of force into magnitude and the distance from perpendicular distance from point to the line of action of the force. So, in this case d equals to r sin theta and F is the magnitude. So, this actually this formula we can use for other purposes. Now, what is the magnitude of the moment? Therefore, the magnitude of the moment equals to m p equals to d into F. So, we know that vectors m p and F, this equation can be solved for perpendicular distance. So, using this relation sometimes we can find out the perpendicular distance from a point to the line of action of the force. Now, what is the direction of a moment? So, the cross product m p is perpendicular to both r cross product. So, r and F. So, this vector, that means it is perpendicular to the plane containing r and F. So, this is the direction, this is the actually direction of the moment vector. Now, one important theorem already I have mentioned earlier, that Varignon's theorem or principle of moments. This theorem states that the sum of moments of all forces of a concurrent force system about a given point is equal to the moment created by the resultant moment created by the resultant force of the system about the point. Now, let us explain it. Let there are f 1, f 2 like that f n, n concurrent system of forces are there. So, here f 1 to f n, these are the system of forces, all are concurrent force, they are passing through the point q. Now, we are interested to find out the moment of these forces about point P. So, we will take the cross product of r p q into cross f 1, r p q cross f 2, this way we will take the sum of all the moments, and this will be, according to this theorem, this will be r p q equals to f 1, f 2, f 3, f n. That means, the resultant force of these n forces. So, r p q into resultant force. This is the relation. So, if you find out the resultant force and multiply cross product with RPQ, then you will get the those that is this is equal to the sum of the all the individual moments. So, this property was originally developed by French mathematician Varignon. Now, we will apply this Varignon theorem for some problems. Here one example, one bracket is there and 400 Newton force acts on this bracket, and we have to determine this moment of the force about point O. So, how we will proceed? So, there are again two ways. One is scalar method, that means we can find out the components of this force and then determine the moment of each about O on its line of action and then sum this. Another way is we can use vector analysis method using vector. So, let us see these two methods one by one. In scalar analysis, first method what we do, we find out the two components horizontal and vertical. So, 400 Newton, 400 cos 30 degree Newton and sin 30 degree this way. So, 2 meter is the distance for the horizontal component and 5 meter is the distance moment term for the vertical component. So, 5 meter into 400 sin 30 degree n and 2 meter, and these all both the forces, both the components actually try to rotate clockwise, that is why their signs are negative. So, ultimately we get minus 1.69 kilonewton meter. In vector method, we do not go for the components, directly we find out a vector from the point of rotation to the application point of the force. So, here we are finding out r. So, from O, that point of application of the force, the horizontal distance is 5 meter. So, it is along x axis, that is why I 5 I, and vertical component is 2 meter. So, it is 2 j and it is all are in meter. So, 5 I plus 2 j is the position vector. So, and force we already know 400 Newton. So, 400 Newton we are taking the components, horizontal component will be 400 cos 30 degree I and vertical component will be 400 sin 30 degree j. So, these two vectors we take the cross product and ultimately we get this in the z direction, that is k direction, the vector, the moment vector, this magnitude is 1.69 and it is in negative direction, and its direction actually it is opposite to k, k means I j k, it is z direction, opposite to the z direction, positive direction of the z. This way we can find out. Now, here in most of the two dimensional situation like this, we find the two dimensional description of the moment easier to use in actually we sometimes we may ask that it may be questioned that which method we shall follow. So, normally in general for two dimensional cases we may use this scalar method or using components of the force, and in case of three dimensional situation we will use vector method. Next, how to determine the moment and perpendicular distance to line of action. Here this is one problem we will solve here. So, a 90 Newton force is applied, F is the 90 Newton force, and it passes through the point B to C. So, we want to find out what is the moment of A F about A and what is the perpendicular distance from A to F. So, what will be the approach? the approach is, since r is a vector from A to any point on line f, we can either find out the vector from A to B or A to C. And since the, so first we will find out the this position vector and then the magnitude of f. So, let us do one by one. So, we want to find out first the force F. We know the magnitude is 90, but what is the direction? So, unit vector we have to find out. So, for finding out the unit vector, what we do? The vector at C, position vector at C minus position vector at B, that is 7 minus 11 I plus, that means the C is actually 7 I, 7 j, 7 I plus 7 j plus 0 k, and point B is 11 0 4. So, 11 I, 0 j and 4 k. So, these two vectors, if you actually take the difference of the two vectors, then 7 minus 11 I, 7 minus 0 j, 0 minus 4 k. So, 4 minus 4 I plus 7 j minus 4 k, this much of, this is the distance anyway. So, this is the position unit, this is the vector from B to C. What is the magnitude of this vector? Just you take the components, square and add and take the root, it becomes 9. So, now you can, you know the vector and you know the magnitude, you can convert it to unit vector E B C by that 4 by 9, 7 by 9, 4 by 9, this way you can convert it into unit vector. So, the F's direction is in the unit vector E B C, but you know the magnitude. So, multiply the magnitude with this, with the unit vector, then you get the force vector as minus 40 I plus 70 j minus 40 k Newton. So, next thing is we have to find out the position vector. We have found out the force vector. Now, we have to find out the position vector. So, there are two ways, one is R A B, another is R A C. First, let us consider the position vector from A to B. Same way the earlier one, we can find out the 11 minus 0, that is A B, these two coordinates I j k, from that you can find out. Then you take the cross product M A equals to R A B cross F, and then you get this 307 j. This is the moment of this force F about A. Another alternative choice is R A C. If you take this position vector, so M A equals to R A C cross F. Here also you will get the same value M A. If you calculate it through R A C, you will also same value. In earlier page we have seen. So, here also 300 I, 480 j, 530 k. Here through A B, here through A C also you get the same result. Now, what is the perpendicular distance? How we will find out? Already we have given one formula that magnitude of the moment equals to magnitude of the force into perpendicular distance. So, perpendicular distance we can find out by dividing the magnitude of the moment by magnitude of the force. So, if we use this, we will get this value 8.66 meter. Now, there will be questions that how do you describe the direction of moment in 2 dimension case. So, in 2 dimension description, the direction of moment is specified in normally in counterclockwise or clockwise direction, that way we mention in 2 dimensional case. In case of 3 dimensional case, we denote by the vector. From vector's direction we can tell the direction of the moment. Now, what is the moment of a force about a line? Up till now we have found out about a point. Now, we want to find out the force about a line. So, the measure of the tendency of a force to cause rotation about a line or axis is called the moment of force about the line. Suppose that a force F acts on an object such as a turbine that rotates about an axis L. So, what happened? We resolve the force into components in terms of the coordinate system. So, in the next figure we see that this is the turbine and L is the line, this is the axis of the turbine, and force F is being applied at point P. So, the force F at point P can be resolved into three components F x, F y and F z, and from the figure we can see that only the F y is responsible for the rotation of the turbine, but other two forces cannot rotate the turbine. Now, how to determine the force about a line? So, suppose L is a line and F is a force. So, how to do that? We first let us find out the moment about a point P on the line L. So, this moment will be m p equals to r cross F. Now, we want to find out that which moment component will be responsible for the rotation of the turbine. So, moment of F about L is component of m p parallel to L. So, we have to take, so m p is the main component. Now, if that means the distance from P about P we have found out the moment of F. Now, we want to find out what is the component of that moment along L, and that component we call m L, which is shown in this figure. So, that we want to find out, and then the thumb of the right hand is pointed in the direction of m L, and the arc of the fingers indicates the direction of the moment. So, how we will find out? So, m L how we will find out? First we will find out the unit vector along L, E unit vector, then you multiply dot product with unit vector and dot product with m p, then we will find out the component of m p along the L line L. Then, so this is the magnitude of m L, and we know that this vector m L will be along the L direction along the line L. So, unit vector along L is E, that is why m L equals to E dot m p into E, and we already know that m p equals to r cross F. So, if we put that thing in equation 1, then m n will be E dot, in place of m p we put r cross F dot E. So, here we got a, within the square bracket we get a triple product of E dot r cross F. So, E dot r cross F equals to E x, E y, E z, r x, r y, r z, f x, f y, f z, all the components we write, and this way we can find out the m L. Now, next question is that when you are finding out the moment about the line, we are taking a particular point on a line. Does it create any problem? So, in this figure we have shown that it does not matter the position vector you can take, because when we are taking the position vector, that means about point P on the line L or point P dash we take, matter is the same, that is shown here. That is that m L already we have already found out the expression m L equals to E dot r cross F E. Now, if we take another point in place of P, another point we take P dashed and the position vector is r dashed, then E dot r cross F equals to r plus u, because p and u, the distance between these, that means r dash equals to u dash u plus r, these two vectors. So, u plus r we are putting in place of r dash, and u cross f, this is perpendicular to E. So, dot product u cross f is perpendicular to E. So, the dot product will be 0. So, the second term within the square bracket will be 0. So, the term remains E dot r cross f. So, this way you can show that wherever point you take on this line, it does not matter, you get the same value for the ML. Here we have applied that method for a numerical problem, that is determine the moment of a force about an arbitrary line. See here again the force is F equals to 10 I plus 60 J minus 20 K Newton, and line L is between the 2 points A, that is 2, 0, 4 and B is minus 7, 6, 2. Now, we have to determine the moment of a force about the line, that means we have to find out the ML, what we have done. See here again we have to find out the R. So, from AB we can find out the R. So, because AB means position of, that means B vector, position vector of B and position vector of A. If you just subtract these two vectors, B from position vector of B, the position vector of A is subtracted, you will get 8 minus 2 I, 6 minus 0 J plus 4 minus 4 K. So, 6 I plus 6 J meter. So, this way you get the R vector. Next, what we will do, the force already is given in terms of I j k. So, M A equals to R cross F. So, I j, so we can find out from R cross F the vector M A, and E A B to obtain the unit vector for there we have found out. So, that we can find out from A B vector. So, once we get the E A B, we can find out this M L using the earlier formula what we have shown there. So, using the same formula we can get 109 E A B Newton meter, and instead of E A B if you use B A, sign will be opposite, that can be shown. Now, we are come to the another special case, that is when we are dealing with all the forces, but a special case is when two parallel forces that have the same magnitude, but they have opposite direction and separated by a perpendicular distance d. So, since the resultant force of the two forces composing a couple is 0, because they cancel each other, but there is a pure moment. So, it has a tendency to rotate in a specific direction. This is the property of the couple. Now, how to determine the moment of a couple? So, the moment produced by a couple is equivalent to the moment of each of the forces. So, separately if you find out the moment of each of the force individually and sum them, you will get. So, in the figure we can see that at A the force is plus F, and at point B the force is in the opposite direction, same amount, same magnitude. So, minus F. Now, if we use that moment about O equals to R A, already just another thing, if we remember that the position vectors are R A and R B. O to A, this vector is called R A, and position from O to B, this vector is called R B. So, these two vectors we have found out, R A cross minus F plus R B cross F. So, equals to R A R B minus R A cross F equals to r cross f. So, it does not matter about which point you took, it always remains same. It depends only on the perpendicular distance between these two, that means two forces of the couple. So, this way it position vector, by that means distance between these two and the magnitude of the forces. Here one problem we are going to solve, how to find out the moment of a couple. See, here is the couple, two forces equal and opposite, and their positions are given 6, 6, 0, another is 8, 3, 0. Now, we want to the F is the lower force is F and upper force is same magnitude, but opposite direction. So, minus F. Now, here the what is the approach of solution? Calculate the sum of the moments of the force about a point and sum of the moments of the couples formed by x and y of the components. So, here two ways you can do. Directly you can take the moments of the force, and another is each force of the couple can be resolved into their components, and then we can find out. So, here you can see that force F and minus F, these are the two forces at the two location, 2 points 8, 3, 0 and 6, 6, 0, and the position vector from one point to another is r. So, m equals to r cross f, because if we take about the application point of f, then r is the about that point, r is the position vector and minus f is the force. So, r cross minus f, we get the 22 k, this is the direction in k direction, z direction. So, Newton meter. Another way is we take the component, first we take the component x components of these both the forces of the couple. So, its amount will be 10 Newton and locations already it is given. So, what is the difference between these, the in y direction, what is the distance between these two forces? These two forces in y direction is 3, y direction because 6, 6, 0 and 8, 3, 0. So, 3 meter is the gap between these two forces. So, that is the arm, and 10 is the 3 meter into 10 Newton is the force. So, due to the x components we get the moment 30 Newton meter, and then vertical component if we find out similar way, the x component this vertical component is 4 Newton magnitude, but the distance in the x direction between these two forces two components are 2. So, we can find out 2 meter into 4 Newton equals to 8, and we can see that these forces is trying to rotate in clockwise direction. So, it is the negative direction. So, negative sign will be there. So, here in the first method, how do we choose the point about which the sum of the moment? So, here the answer is we can choose any point, but for simplicity we can use the point of application of f. That way the moment about that point of f due to f will be 0, only we have to calculate the moment for minus f. So, and if we take any other point also, the result will be same, because we have taken one point that is application point of a for minus f, but instead of that you take another new point, then also the result will come the same. So, here we can show that if we take another point, so from point P, the for each force we have got the position vector r1 and r2, and we find out the calculate the moments r1 cross f and r2 cross minus f, and if we apply this thing we get the same result. So, the position does not problem, we get the same result. So, in this session the few important concepts, that is moment. The concept of moment describe the turning effect of a force with respect to the point of interest, and the sense of rotational tendency gives the sense of moment clockwise or counterclockwise. The magnitude of moment m a of a force F about a point A is defined by a scalar quantity m a equals to f d, where d is the nearest distance between A to the line of the action F, and the terms lever arm or moment arm are sometimes used for T. Moment of a force about a line, commonly in practice a body is constrained to rotate about a given axis regardless of the direction of forces acting on it. So, if the resultant of the forces acts in a plane that is perpendicular to the axis, the concepts of moment about a point can be used directly. So, that we have done when we have found out the ML, we have found out along the axis component, and that way that is only capable of rotating the turbine, other components are not capable. So, that way we are finding out. Another important concept is Varignon theorem. See, sum of moments of all the forces of a concurrent force system about a point is equal to the moment created by the resultant force of the system about the point. And couple is a pair of forces that are equal in magnitude, parallel in lines of action and opposite in direction is called a couple. Moment of a couple is the magnitude of moment of a couple is given by m equals to f into d, where d is the distance between the lines of action of the forces of magnitude f. Now, for studying this chapter, I suggest some references, that is Bedford and Fowler, Bella Sander, then Johnston, then Hibbeler, K.L. Kumar and Sims. These books can be read. Many other books are there, but these are very renowned books. So, next unit we will discuss about the equivalence of forces. So, with this we end this chapter. Thank you.